Okay, hi everybody. This is the Math 31 optimization review. This is question 17. This is a bit of a difficult question just in terms of getting the diagram correct here. Other than that, it's not too bad. So what we've got here is a jet, okay, and it's going to be flying east here. So we might as well put it out here. Here's jet A, and it is flying east. Okay, it's 600 kilometers per hour. Okay, and then there's another jet. This is the where you gotta get your head wrapped around this. It's 60 kilometers away. So this distance right here is going to be 60 kilometers. But this other one is also 100 kilometers north. Okay, so we're going to put this one up here. This is jet B, and it's coming down at 700 kilometers per hour. Okay, and it's 100 kilometers up. And so what we're going to try to do here is figure out the minimum distance between these two, so we'll call that D. Now we're going to set up the Pythagorean theorem, and so we're going to take a look at this triangle that's left over. So D squared, okay, is going to equal the distance that the plane A is, let's say from that origin there, okay, which will be 60 minus 600t squared, okay, because it starts off at 60 units away, 60 kilometers away. And then the plane is going to travel 600 times t. And so that distance minus this distance will be the distance that the plane is away from the vertex or the right angle in this triangle. Now, by the exact same logic, okay, that other plane is going to start at 100 kilometers up, and it's going to lose 700t all squared. Now that we've got a relationship here between distance and time, what we'll do is we'll take the derivative. We'll do this like this, okay, implicitly really. Take the derivative with respect to time. This will be 60 minus 600t times negative 600 plus 2 times 100 minus 700t, okay, times negative 700. Now, we can cancel out the 2's right away, which is kind of convenient, and then I'm going to divide by that d. But I'm going to expand this all out here first. So this is going to end up being negative 36, 1, 2, 3, plus 36, 1, 2, 3, 4, t. Okay, and then this is going to be, what do we got here? Minus 7, 1, 2, 3, 4. And then this will be plus 49, 1, 2, 3, 4, t. Okay. Really big numbers here. We're going to divide this all by d. Okay, so there's the derivative of distance. Now what we're going to do is we're going to set that equal to 0. Okay, now because it's equal to 0, I'm going to multiply through by d just to get rid of that, so the denominator is no longer the issue. And then I'm going to add together the terms here. So I'm going to get 85. Actually, sorry, that's 850,000 t minus, and what do we got here? We've got 73, so it looks like 106. Is that right? 106,000? Yep. Yeah, looks like that. Is going to equal 0. And so t is going to equal, well, it's going to be 106,000 divided by 850. And this is going to equal 0.12 hours. Okay, so the question is asking for what is the minimum separation of the planes, and what is the time at which this occurs here? Okay, well, it's going to occur at 0.12 hours after 9 o'clock here. Now I'll deal with that in a second. What I'm going to do first of all is I'm going to take that number and I'm going to determine the minimum separation by going back up to the original expression here. I'm going to plug that in. So this is going to end up being the square root of 60 minus 600t. Okay, and that will be squared plus bracket here, and I've got 100 minus 700 times our answer, and again that will be all squared. Okay, so our minimum separation here is going to be 19.5 kilometers. Okay, now I'm going to go back and I'm going to figure out what that 0.12 is. Okay, well that 0.12, if you multiply that by 60, because that's what that is, it's a fraction of an hour. I'm going to convert that to minutes. So basically this is going to occur, therefore, sorry, it's not equal to, but therefore this is going to occur at 9:07. Okay, and a half. Okay, and like, what is that, like almost 30 seconds. Yeah, anyway, there you go.